Hello guys, today we're going to see about a simple machine learning project overview. Today the topic we have taken is like predicting the trip fare. Okay, the topic itself says something we're going to predict the total amount of the trip. The trip itself, our mind goes to the duration of the trip, the distance of the trip, and how many passengers are going to travel. So by entering all those basic details, we're going to get the estimated trip fare. Yes, guys, this is what problem, the title, and do think about it. This is a regression problem or a classification problem. Let me give a simple hint of that. Regression is the one which is used to predict the continuous values, like a target variable is in continuous range. Whether in classification or target variable in discrete, either we are going to predict zeros and ones. So do think about it. It is a regression or classification problem. Meanwhile, let me show you my Streamlit UI. So here it is I made. So as I said, by entering the basic trip details, so here I'm adjusting the number of passengers would be 2. The trip distance would be 25. The duration it may take around 40. So here is the other features as well. I'm using cache itself. So I'm predicting my fare. So yeah, it's around $53.57 for 40 minutes, 25 kilometers, the two passengers at 12 o'clock, the trip has been happened. So in behind what the process has been happening. So behind there is some machine learning algorithm works with to get the output, right? So today we're going to see that. So firstly, here's the project flow. Firstly, we have to incorporate the Python libraries here I have made in the EDA. Guys, you have a basic idea about the EDA, right? EDA is the exploratory data analysis. It's all about the data. Firstly, EDA starts with understanding the data. Then we have to clean the data if there is any null or duplicates. Then we have to do handle the outliers that comes under handling the irrelevant data. And there is a feature engineering or feature scaling or feature transformations. Guys, at EDA, at last we have to make sure our data is well prepared for model prediction, right? And there is some visualization, let me show in my project, and machine learning algorithms. Guys, what's on your thought? It is a regression problem, as our target variable is we are predicting the total amount, right? So it is in continuous range, so it is a regression problem, so we'll be applying a regression algorithms here. Then here is the streamlit application I have shown to you. So firstly, incorporating the necessary libraries. Here is the taxifare CSV file. So here it is. So it's still loading. Let me show you. Just a minute. Let it download. We'll get into that. So here is the header file. The top 5 records shows here. Starts with understanding the data. It is about 18 features, having a 2 lakh, around 2 lakh rows in it. At starting, we all used to do a describe and info as same I did for understanding the data, mostly on float, some of in object, some of in int. I'm checking is there any null. Fortunately, guys, there is no null values in my data and duplicate as well. After that, here the pre-processing for data sets starts with. Yes, actually, the data set which I has, it is a New York data set. The taxes which is running in New York. So it is the actual CSV file that I have inserted here. I have shown, right? Is here I'm converting into the into daytime data type, right? It is an object, so I'm converting into the daytime object. After that, I'm doing a feature engineering. Guys, you have some idea about feature engineering is something creating a new column, new feature from the existing one. Here I'm saying that feature is nothing but a column. We used to refer as a feature here. So here we may see there is no trip minutes, trip duration, trip distance, and all. So indirectly, there is something like longitude, longitude of the pickup and drop off, right? From that, we may calculate the trip distance. So by using Haversine formula. So in free time, do check it out, Haversine formula. From using these 4 columns, I'm just creating a distance of my trip. Okay, secondly, I'm creating a new another column like a trip duration from a drop off and a pickup timing, guys. Then I'm creating new columns: pickup hour, is there a weekend or not, and AM PM, it is night. If it is about 10 o'clock and below 5 o'clock, it has been considered as a night time, referred as one, else it is a no. As same. After that, now I'm checking the columns, it is around plus 20 something, guys. So actually there is no need to keep all the columns, which wouldn't make any sense to predict my target variable. So here, what is my target variable, guys? So by having all the features, what I am going to predict, guys, what is my target variable? Here my target variable is total amount. By having all the other features, I'm going to predict my total amount, right? So there is no need to keep all the columns, which make doesn't make any sense to my target variable. I'm dropping that. And here the longitude and latitude, which we have extracted through a trip distance, right? So we may drop that. Yes, guys. After I am describing it, I could found out the passenger count. A minimum is zero, right? A passenger count is zero. How the trip is going to happen? No, right? There is some data entry error like that, and a rate code which is around 99, which doesn't make any sense, and a payment type. And the here is the continuous columns, guys. A trip amount, a trip distance, and a duration. We may see the values is something in negative and a zeros, right? And we see the maximum is like around 1000 plus. Okay, it says there is a huge outliers present in my data set. So here how I'm going to handle it in future. So here I have noticed, I have summarized it what I have noticed above. I have noticed nine rows has been zero passenger count, so I'm just removing that. Same applies to the rate code ID. Rate code ID is something a numeric code which indicates structure of the particular trip, right? So here 99 is unknown, so I'm just neglecting from my data set, which doesn't make any sense. Then I am checking the trip duration, guys, which is around 131 rows below a zero, which has a negative values here. See, here trip minutes around 0000. So how it's going to happen in my data set? The possible reasons would be a system error, data entry mistakes, or unusual trip patterns. Okay, so I'm just removing all the values which is less than 0 and 0. And in total amount, same I'm doing that. So why have to remove that instead of keeping that? Here my target variable is predicting the fare, right? To make a generalized model, I may remove that. Okay, suppose if I am making a model for taxi behavior, fraud detection and all, I may keep separately all those negative values and zero to make some insights on that. So here my target variable is a trip fare prediction, fare predicting. So I'm just removing all my anomalies like zeros and less than zero. Same I am doing for a trip distance. After that, here I'm checking the East weekend. All are like there is all weekday. There is no weekend. So there is no difference on that, and no need to keep this column. So here, therefore, I'm neglecting that column as well. After that, as I discussed, is the visualization part starts with. Firstly, I'm visualizing my passenger count. Here is mostly like a uniform distribution. All of the passenger count plays an equal role. Then is night pickup hour, guys. Mostly the pickup has been happened at 3 o'clock, mostly at a night time, early morning. Okay, then these are all the visualization parts which takes place here. So there is time we'll see clearly each and everything. Here I'm explaining the basic concepts. Then I am checking the skewness. Skewness, you know, right? If you're predicting a model, that should be a normal distributed, a Gaussian distribution. Sometimes we may say a bell curve, right? I'm checking the skewness. It is very highly skewed. It is like 5.22.24 point. It shows like. And here in the plots, we may clearly see it is long tail on the right side. It's positively skewed. To make it a normal distribution, we have to use some transformation. Before that, I'm checking an outlier, right? Firstly, we have to handle the outlier, then we go with the transformation. This is the thing we do mostly. So here I'm checking the outlier deduction, guys. So there is high outliers. See, the tip duration, it goes around 1500. The distance goes around above 8000 and all. Okay, for handling the outlays, I'm using the winsorization method, like a capping method. all the values that extreme to the higher friends, the value is capped with the higher bound. Okay, the values which is below to the lower bound, which has been capped with the lower bound. Okay, here it is. Just check it out what is capping and all, you may get to know some idea. So after doing that, all my data has been capped successfully and there is no outliers in this. So now after outlier handling, now I'm checking my skewness, which is dramatically decreased, guys. We may see it almost normal distributed, though it has somewhat positively skewed. Okay, to make it a normal distribution, I'm applying a log transformation for positively skewed data. So here it is. Here I'm applying log 1p. So after that, we may see somewhat it's like a positively distributed. Now I'm checking it almost comes under the value of 0. So it is close to the symmetric distribution. Now here is my total features. Around it has 9 features, includes one target variable. Here we may see all are in floats and integers. One is in object. So machine can only understand the numeric data is right. So here one is in object. So I'm doing an encoding. Encoding is nothing but converting a categorical variable into a numeric form. So I'm replacing AM with 0 and PM with 1. After that, it is very much important to reset our index. For my model prediction, we'll be splitting our data set, right? So there will be a problem. So I'm just resetting my index accordingly. Is the feature selection. Feature selection is nothing but there will be 8 features, 8 independent features. So it is helpful for choosing a best feature for my model prediction. Okay, from here I could see the trip distance, a duration plays a major role. Here it's around 0.91% contribution to my target variable. Okay, after that I'm keeping all the columns. So here is the trip duration versus amount. As the duration increases, my total amount also increasing state. So it forms a linear line. So clearly we may see it is better to apply a linear regression on that. So guys, successfully we are in a model building. So first step of the model building is the splitting the x and y. X takes place the independent variables and y takes place the dependent variable, which is my target column. Here is the total amount. Splitting the test size I'm giving is a 20 percentage and my training data would be 80 percentage. Here I'm checking the length. The first model I'm using the linear regression. Simply I'm calling the linear regression methodology using the sklearn. I'm just fitting into my training model and I'm predicting my X test. Here I get around 93 percentage of my accuracy. Same I'm applying into the ridge. Ridge is the regularization method of the linear regression. Here same I'm getting around 93, and I used lasso. Using lasso I get around 73, which is less compared to the before models. So no need to focus on that lasso. Then I'm using a random forest. It's like a tree based model, guys, right? And using a random forest, same I flip fitting and predicting. Random forest works according to the decision tree. Here I am estimator put 100, and the random state means it won't shuffle each time when we enter a data. Okay, if you wouldn't provide a random state, each time when we run the model, it will give a new training and testing data, right? In a random state we may give any value. The 42 is a standard format, but we may give any value, 11 or 22, whatever. By using random forest I get around 96%. And last model I'm using a gradient boosting, which I get around 96. So here, which is actually my model is performing well with that. It's actually giving me around 96% of accuracy. Then hyperparameter tuning. From the above 5 models, I'm choosing any one of the model which performs good to tune my parameter to get though better results. Okay. There is two ways: a grid search CV and randomized CV. I'm using a grid search CV. This hyperparameter is nothing but adjusting our parameters. Parameters is like that, adjusting our parameters to get the better accuracy, right? Though I'm using an hyperparameter tuning, I get around 96% accuracy. Same we get on a random forest. Like, yeah. So I'm pickling. Once we run our data, so guys, as soon as possible, just pickle it your model for a feature reference. Here I am pickling my linear regression, my grid random forest, and my simple random forest, right? So after pickling, here is my here is how I have created my streamlit. have applied the linear regression on that. So at last, here is the uh, UI of my project. So let's play a game. Like I'm just entering as 22, and my duration it takes around what I will play is like okay, I'll place at 28. Here I'm going at PM. I'm using digital wallet, and the passenger I'm giving as 3, and I'm predicting the fare it's around $33.6, guys. So here is was a simple machine learning project that I have created using a simple linear regression. We may use that. Thank you.